Okay, so first of all, I was using this decorators pattern that we heavily use on Angular to make some changes on the project I was working, and and now I see that the decorators should be something that we could share. It's basic stuff, but I guess it's relevant for each other. So uh, thank you for your time, guys. First is we have some basic types of decorators. That is the class, method, uh, accessors, properties, and parameters. And each of these are just applied to classes. So you can have the metadata for the classes and use it as as you wish. And for this presentation, I'm going to show some examples of class and method and property decorators. And how to create that. You can use the directive function that is the decorator itself. That is the function that depends on the type of decorator. For example, if you want to create a decorator for a class, you have a function that receives the constructor of the class. So you can seal it, you can add another methods, you can add, you can transform the object of the class that you instantiated. And you also have the pattern that is a decorator factory. That is a function that you can pass parameters for it, and it's evaluated before it's been executed on the site of your metadata execution and exporting and importing the files of the object. The order are not a good hint for that, but you can always look for the docs from the Typescript decorators. This is the right order. So it starts from the parameters decorator, method, accessor property, and for each instance first, and then the same pattern for the static members. After that, you have the decorators for the constructor, and then you have the class decorators. So the class is the last, at least this is the pattern that you can follow on the top of your mind. The class is the last. The decorators within the class are method, accessor, property, and first for instance, and then for the static members. So the presentation is that talk is cheap, and so I'll show the code. Let's share. Okay. First, the code itself is trying to make this self-explanatory, but as we can see here, I tried to build some sample based on the Express framework. We're creating a route for some class. The things that I'm trying to expose here is the metadata is being stored in some place and use it a functional style or what have you for creating decorator-based CRUD application. It's simpler than that, but it's just creating these functions that I can define the basic styles or things that I have for the routes, and use that as metadata to create the structure of the API. So I'm going to pass this. Basically, it tries to create the route. Creates is for creation. You allow the method to create this. Basically, it's a post method. Read one to to be able to read one of that created to-dos here. And we have some data storage to create it. Basically, it's in memory, but you can define it as you wish to store it on database and retrieve the data from there. Each one of these is created on customization, and all of it are following the pattern that I have used it before. So it's an entity where I can store that data, that metadata, and build the API. So I'll share the basic stuff here. That is, it's simple. It's a Express application. I have a body parser, and build routes is basically all of that metadata being stored in somewhere and being retrieved from that object. So, and all of that have to be followed by the import of the things that you're storing, because these decorators are being fetched and executed, evaluated, but they have to be imported, because otherwise the construction of the objects will not follow that unless you start some new object here. So you have to store that information of importing the object. I will run the application here and start and show the example. So here we have some pre-built routes, and this is for the creation, and this one is for the retrieval of one of the to-dos. So I'll share. This is only like a postman, but it's for the VS Code. So on the creation, we required the description of the to-do, and it starts default for done as false and returns the entity instantiated. So you can post, and it creates the entity. It's following that pattern that I mentioned. So you can retrieve here with to-dos. You have one here, and then you can send that. Yeah, that's kind of, let me share. Second one. So you have second one, you can retrieve the first. It's all been stored on memory, so every time I reset this server, it will be cleaned. Let's show the implementation for it. I have to be smaller. So yeah, for the implementation, you have to store the data for the routes. So I will pass from the creation. The creation is basically I'm storing the as it is a class class decorator. You have the access to the constructor. So you have to return a function. This is a decorator factory, and you have to return the function that is using the same pattern that is required from the. You can show, you can refer to it on the TypeScript docs. The class decorator has one function that returns that has this first parameter that is the constructor, and you have to return the constructor at the end of it, so you can set it to the pattern that TypeScript uses for the decorators. Here I'm trying to get the stored the path for the API on the stored object. So if you don't have that, you return the subpath. It's just a property that I'm using there, so I can create some naming for it and define the things that I want. And I have stored a handler that is a request, response, and next function. It's following the express pattern for handlers. And here I have some requirements from the required fields. If we have all required fields that we store here, it's just example for it. You don't have to do that, but it's a required field that I try to check if the object I'm posting there, it has this field. And if it has all the required fields, I create that from the repo that I previously stored. If don't, I return something that is not present and return the errors. And I store the handler, the method, and the path that I want to this handler. I also store that using the same base for the constructor name, and then return the constructor, and that's it. You can have this function that is handling the creation for the object, and you don't have to do anything else for that using this behavior. And I think that's it. I will show the creation of the routes. So for each route, the build routes following this is a router from Express Framework. It checks the keys that is there and the star objects. I check every subpath that we have there. That's just a key that I defined. And I use this method. I'm lowercasing here because I want to access the method from the router that is post on that example. And the star subbase is the base of the object that I'm defining on the route decorator. And the subpath is the path that I want that. For example, for this to do, I have this subpath. And for the creation, I have the slash at the end. And then I pass the handler and it's all stored. I return the router that I have created with all the entities, all the base paths and the subpaths for that entity. And the Express framework builds it. And for now, I will show one example for the ReadAll, that is a get for only the API to-dos. It's called ReadAll. It's not implemented yet, so I will save this after implemented. Okay, I have this base function here. So ReadAll, I required to create a function that follows the same pattern, that has a constructor, this type T, and I will return it. I'll follow this pattern. So we'll fetch the controller, fetch the subpaths that I have, this start data. I'll copy this one to make it simpler. The only thing I'm gonna do here is override the subpath. I have the handler. I don't have to get only one from the repos, and the repos I'll get all. And the entity, I'll call entities because it's multiple. We will return to that in a moment. And that's it. ReadAll has these entities returned from the controller stored repo. And now the ReadAll, I can save it. And now we have this. Oh, it's missing one thing. One thing here. Clean up. Subpath is the slash at the end. And now we have this base get function. So we can create multiples. Second one. Etc. And now we have this function available, and we can return all the stored objects. And I'll show a last example, that is the transform. The transform I can is being applied for one property. So I have the description here. It's a function that I have to define, and I can transform this description to something else. As you can see, it's only memory stored, so I'll create again. And the transform just get me, oh, the transform is getting me. Yeah, basically the transform is making some weird behavior here, but yeah, I guess that's it. If you have some questions, I'm glad to answer.
Gilberto, Mariano, I have one question.
Hmm?
So first of all, it looks very good. Basically, when you have the annotations behind the to-do class, right? Are they following an order? Or, for example, if I want to add one called validation, right, in the class, but I want this to run before the create.
Okay, yeah, the order for the, you have two things on this factor decorators. You have this function that are all factors. So the function is evaluated on this order, yeah, from the top to the bottom. If you have to switch orders of evaluation, you have to switch the order of the functions here, the function column. And the execution of the inner function that you're returning occurs on the opposite order, from the bottom to top. If you have you have this requirement, you have to be careful of the order that you're applying. It executes on the same order on the other decorator sites.
Perfect. Well. Thank you.
I have one question too, Gilberto. So if you were to add testing for this, how would you approach the testing? Would you, I mean, an open question. I think I have an idea, but I want to hear your opinion.
Yeah, if you want to test, first you have to be specific of the entities you're storing. For this, you're creating on this behalf, you have creating a static variable that is widely available for all the application on this example, but you have to create some instance of that to make this stored object that you can refer on the text. For example, this, let me check here. This object here that is storing all the information for the route creation, you can't have this as a test exactly because you have to reset the object every time you have a test to make it consistent for unit testing on this case. You would have to make this object some instantiatable object that you pass for some storage being access to create the transform, the data repository for it. So you have to be, I'm being explicit here that this is not a good pattern that you can follow because it's storing a global variable here. So it depends on the state. For the functions, you have to test the behavior for that based on the transformation that you have on this object. So that's the problem on this example. You have an object that is being modified by the functions that you're calling on the entities that you call, so that I called here entities. But what have you? You have to test this this function returning something, or you can test this state that you're saving there. I don't know if I have answered your question.
Yeah, pretty much. Thanks a lot.
Any more questions?
I have one more, and maybe there is no answer to that, but in your experience using Decorator, is there a situation in which you will avoid them, which is a bad idea to generalize functionality in Decorators?
Well, for the application that I made on these Decorators, we used that to replace some kind of query builder that we have there. We don't want to create a ORM from scratch because that's a thing to avoid. Create something that already exists is using engineering time that's not required. You don't need to have that. But if you over-engineer too much, you would end up having too much decorators for doing stuff that you don't need. Basically, transform here is one example of things that maybe you can have that transform data, but if you start creating a lot of specific times of transform, you have something that is loaded of code that you don't need. That the intent of this talk is to reduce the amount of code that you want to write to make some simple stuff like that. I guess.
Yeah, the risk is to get too enthusiastic about the power of Decorators and start using them even for things that are not necessary, I guess.
Yeah, I guess that.
Cool, thanks a lot, Gilberto.
Thanks.
Very good, Gilberto.
Thank you.
All right.
Excellent
so, yeah, very, very good talk, very interesting. I will, as usual, upload this to YouTube. And I'm curious about the source code. I want to read the code and get more familiar with it. It looks great. Thanks a lot.
Thank you. It's all on the GitHub.
And you guys have a challenge. You have to make transforms transform works, right?
Yeah.
There you go.
Okay, cool.
Cool.
Thanks a lot, guys. I will upload the video and let you know on the engineering channel.
Thank you.
Thank you. Bye, guys.
Bye-bye.
Bye-bye.
Bye.
Thank you. Bye-bye.